Hi, Ann Guignon here. So let's get into the whole discussion of acidity in a much deeper level today in this small talk about big thoughts. So let's talk about pH first. And I'm just going to pop off right here and we're going to go through this concept, which is really important for you all to understand. And what we're going to focus on today is titratable acidity. So I'll see you in a few minutes. So if you want to know the relative pH of a product like a drink or maybe a mouthwash, it's really easy to do. And one of my favorite companies for all things testing is Micro Essentials Laboratories. They make excellent pH paper. But you can get it in little rolls, or you can get it in plastic strips with a reagent pad on the end. If you want to look at a liquid, you pour the liquid into a clean container. You can have a half a teaspoon of a product, and you dip the strip in there or the piece of paper and immediately match up the paper to the grid that you see on the package. And then you'll have an accurate pH level. Is not accurate to the level of a scientific lab in a college or a university, but good enough for what we're up to. And you can, if you have a spray product, you just put the pH paper down on a paper towel, spray it, make sure it gets saturated, and now you can take a look at the pH. So knowing pH is one thing, but boy, if that's all you know, you can really get in trouble with understanding where a product is in its ability to set the stage for erosive tooth wear or what we normally call erosion. So this was one of the earliest studies, and it piqued my interest in back when it was published in 2007. Owens and Kitchens looked at four different drinks. They looked at Classic Coke, Diet Coke, Gatorade, and Red Bull. And so to review pH, what pH is a measurement of acidity, and it's only a snapshot in time. It measures the acidity right now, not 10 minutes from now or 20 minutes from now. It's now. And when you're measuring pH, you can only measure pH in products that have hydrogen in them. And that means, in English, that means they have water. So if you have a totally oil based product, you can't use pH paper and get any sense out of it. The second measurement that we can do, but we can't do it at home. This has to be done in a university-based lab or a highly scientific lab. Something called titratable acidity. And what titratable acidity measures is the total number of acid molecules in, say, a drink. And that really tells us the erosive potential. So if you look carefully at this chart on the upper left, you look at Coke and its pH value, which is measured in a little red bar, is 2.49, and Red Bull is 3.41. So if all you knew was pH, you would say, oh, Red Bull's so much safer because Coke is 10 times more acidic. Well, yes, it's 10 times more acidic when you're only looking at pH, but Red Bull is made with multiple organic acids. So the blue bar, which is almost 3 times longer than Coke's blue bar, that is the measure of titratable acidity. So, what this really means is it takes much longer for the body to go for the oral cavity to go back to neutral after drinking the Red Bull, and that's because of the multiple organic acids. So, the total number of hydrogens is greater in the Red Bull, even though the pH is not as low. So here's another chart that from a paper that I read not too long ago, and the researchers said on the top, it's really interesting. Titratable acidity of beverages influences salivary pH recovery. What does that really mean in English? It means that the longer the titratable acidity, or the more effort scientists have to do to titrate the substance to get to neutral, the worse the erosion potential is. And here in red is again the classic Coke. And yes, the pH is lower than orange juice, but it takes less effort for the scientists to actually get to neutrality. So I'm not saying don't drink orange juice, but just understand that it has a much more profound titratable acidity value than Coke. So we're not beating up on individual drinks. These are the list of ingredients that you would find in Mountain Dew. And the ingredients in red are the acids. So again, this is a drink with multiple organic acids. So anytime we see a label that has multiple organic acids, even if you can't find the titratable acidity value, and it's really hard to find, it, you can conclude, pretty safely conclude, that this is going to be a problem. Well, we all have talked about Mountain Dew mouth for years in dentistry, and here's the answer. Not only is the pH low, and I have that value somewhere, but it's quite low. Its titratable acidity is very high. Therefore, the erosion potential is extreme. And if you've ever seen damage in people's mouths who drink beverages like this, you know exactly what I'm talking about. So here's a chart that Dr. David Bartlett from the UK presented about a decade ago at an ADA meeting in San Antonio. And I was fascinated by this because this was my early understanding of titratable acidity. And you can see on this chart that carbonated water, the pH isn't ideal, but the titratable acidity is really low as compared to, look at apple juice on down there. The pH is considerably more profound, and the titratable acidity is way off the charts. And look at grapefruit juice. So it's not just drinks with multiple organic acids, it's all kinds of beverages can have really profound titratable acidity values. And this also goes for foodstuffs as well. So this will give you an appreciation for the difference between pH and titratable acidity, but how these two values go hand in hand. And I actually discuss this in more depth in my bigger courses, but it's important that you get a basic understanding right now of this. So finally, the final slide I'm going to show today came out of a CE that I put together, and I was looking at medications and found research that talked about pH and titratable acidity of medications. So, if you take a medication once or twice a year, so what? So what? But if someone is on medications every day, day after day after day, then it's conceivable that there could be an impact on the oral health. So this particular study looked at 97 pediatric medications. 57% of those 57 of those medications had a pH value of 5.5 or below. Okay, now we're in trouble. And what they found is that the 15 sugar-free high-strength medications, as compared to the sugar-free lower-strength medications, the high-strength ones had lower pHs and greater or higher titratable acidities. So just because something does or doesn't have sugar in it doesn't let us off the hook, because it's all about both pH and titratable acidity. So there you've got it. So I am back, and wow, the sun is just changing what everything looks like in this video. I didn't suddenly turn orange, I don't think, but I don't think I'm going to redo the video because I think the content's good enough. So I hope that you are getting a better understanding about acids and values. Oh, wow. Now I'm suddenly looking better. So, drop me a note. Tell me what you want to know. Ask me questions. I'll see what I can find out. I'm not a chemist. I'm a dental hygienist. But I'm just curious, and I want to know more about these things. So I hope you have a great rest of your day, and I hope this has piqued your interest. And we will talk later, and we'll have another short talk about big thoughts. So thank you so much for your time. I look forward to more sessions with you. Thank you. Bye.